Next we're going to talk about exponential and logarithm functions. An exponential function, so the functions we've had, like x squared, have had x in the base and a number in the exponent. An exponential function is going to flip that around. It has a number, b, in the base and x in the exponent. And exponential functions grow quite rapidly, much faster than, say, an x squared function or an x cubed function. An exponential function will grow very quickly. And it'll also, notice for negative x values, it'll go down toward 0 as those negative values get larger in negative direction. But b to the x in general, b greater than 1, will always go through 0, 1, because b to the 0, for b larger than 1, is always 1. And in general, this function satisfies the horizontal line test. If it satisfies the horizontal line test, f inverse exists. And we denote f inverse with this notation, log of x with base b. That's a period. That's not like a multiplication. That's a period for the end of the sentence there. Maybe I'll just get rid of that, because sometimes I ignore periods for math purposes. We denote the inverse here, logarithm of x with log of x with base b, and we call this the logarithm of x with base b, Logarithm. So let's look at a sketch of the graph of the logarithm. Well, I'm going to do the logarithm in blue. So there's the line y equals x. We flip this across y equals x. This point 0, 1 is now going to be over here at 1, 0. This piece after it is going to go like that. Notice this exponential function, since it grows quite rapidly, this logarithmic function is going to grow quite slowly. We're going to discuss limits next week and in the following 2 weeks. This still will, even though it grows quite slowly, this logarithm with base b of x, even though it grows quite slowly, it will grow larger than any number, meaning go to infinity. And down here, this piece is going to keep going down, just as this one kept going over. And exponentials and logarithmic functions have some nice properties. I will post some sort of document talking about these exponential properties. Exponential and logarithmic properties. A to the x, a to the y is a to the x plus y. So right here, remember, an exponent just counts how many things you have multiplied together. So like 5 to the 4th is 5 times 5 times 5 times 5. So there are 4 5s. So if you have x copies of a and y copies of a, then overall you have x plus y copies of a. Similarly, if you have x copies of a, x copies of a, x copies of a, y times, then you have x, y total copies of a. And a negative exponent, remember, a negative exponent, all you do is put it in the denominator and it becomes a positive exponent. So a to the negative x, these are all a, these aren't 9s. Sometimes my a's and 9s look similar. So a to the negative x, 1 over a to the x. And we also have corresponding logarithmic properties. So logarithmic properties, the first one, the logarithm of a product splits into a sum. The last one down here, I'm going to skip over 5 for a moment. The last one, logarithm of x to some number. The exponent comes out in front using multiplication. And this fifth one actually is a combination of 5 and is actually a combination of 4 and 3 and 6. That actually is worth going through as an exercise, proving number 5 using 3, 4, and 6. But the logarithm of a quotient is the difference of the logarithms. And what are we going to use these for? Well, we're going to be doing calculus with them in chapters 2, 3, 4, and 5. But until then, what we will do, and actually during some of that we will also use these properties, but right now we would like to see how we can use these to solve equations for x. So for example, we know how to solve this equation for x, 2x equals 5. How do you solve that equation for x? So I would imagine many of you came up with one answer. How about a second answer? How would you solve 2x equals 5 for x? How many ways can you do that? Well, how do you solve it for x? You get rid of the 2. How do you get rid of a 2? You get rid of a 2 by multiplying it by something that turns it into a 1. You multiply by what's known as an inverse reciprocal, an inverse. You invert this 2 and get rid of it, and that allows you to solve for x. You could also say divide by 2. I usually don't like to say divide by 2. So we can solve that function for x using multiplication. But how would we solve this? I guess I should have written it before this. How would we solve this equation for x? 2 to the x equals 5. How do you solve that for x? Well, you can't just divide by 2. That would give you 2 to the x minus 1. That doesn't help. How would you solve that for x? Well, you get rid of the 2. How do you get rid of the 2? Well, you invert this function. The definition of an inverse function is that f composed with f inverse equals just x. Well, we can see that here because an exponential and a logarithm invert each other. An exponential and a logarithm cancel each other out. So you take a logarithm with base 2 of the left side, logarithm with base 2 of 2 to the x, those cancel and you're left with x. Logarithm with base 2 on the right side is just logarithm of 5 with base 2. So now let's look at this example. Solve this equation for x. In this one we are going to use these properties. There are actually two different things you could do first. You could use property 4 first if you want. I'm going to not do that. I'm going to use property 6 first on that root x. So use property 6 on root x. Notice in these, when you split, the bases remain the same. You can't combine, well, we won't combine logarithms with different bases. I mean, that there are certain logarithm properties you can do and convert them, but don't worry about that. So all I did here was property 6 here, root x is x to the 1/2. I brought the 1/2 out front. How do we solve this? Well, if you have in your left hand a $half, and if you have in your right hand a full dollar, how much do you have in your hands? $1.50, also known as 3/2. So if you have a half of a logarithm over here and a full logarithm over here, then overall you have 3/2 of a logarithm. Now, how can we solve this? Well, let's get rid of the 3/2. Get rid of the 3/2, multiply by 2/3. Multiply the left side by 2/3, you get log of 10, or log of x with base 10. Multiply the right side by 2/3, you get 4/3. Now, how do we solve this for x? Well, we need to get rid of the logarithm. How do you get rid of a logarithm? You invert the logarithm using the inverse. The inverse of a logarithm is an exponential. Which exponential are we taking? Well, the base is 10, so we're going to use the exponential 10. 10 to the left side is x. 10 to the right side is 10 to the 4/3. So you get x equals 10 to the 4/3. If you started that by using property 4, well, you'd use property 4 and you would then use property 6 and you would then be at that same third line. Actually, you would also use property 1. So you'd use property, what did I say? If you used property 4 initially, you would use property 4, then property 1, then property 6, and you'd arrive at that line. One final remark on logarithms. Logarithms can take any base larger than 1. But there's a specific base which is a lot more important, at least in calculus and many other branches of math and physics and chemistry and all science. So I'll just say as a remark, there is an important number e, lowercase e, which is approximately equal to 2.71, I think 8 next, and so on. There's an important number e, and logarithm with base e is abbreviated as ln of x. And I'll say, and is read the natural logarithm of x. So when we have this specific base e, we'll write ln of x. I will frequently just say log x for this. I might say natural log sometimes, but I will frequently say log. It will be clear which one I mean based on what is written. But this is an important number, and let's just do one example of solving. Example, solve for x. Let's drop the marker. Let's pick up the marker. Solve for x. Let's do log of 1 over x equals 4. Natural log 1 over x equals 4. Well, first we want, I guess I don't have room down there. You could first use property 6 down here and throw a negative on it. I'm not going to do that first. I will first get rid of the log. How do you get rid of a natural log? You use an exponential. Which exponential? E, in this case. E to the left side is 1 over x. E to the right side is e to the 4. So you have e to the left side, 1 over x, e to the right side, 1 over 4, or e to the 4. And then you just need to solve this for x. You could do what? Multiply by x, divide by e to the 4th. You can just flip both sides around. Either way, you get x equals 1 over e to the 4th. Or you could say e to the negative 4th. It doesn't matter. But these logarithm properties we will use a few times throughout the semester, so they are definitely worth getting used to.